Hello everyone, this is Gayatri from Group 18 and here we are going to give presentation on learning deep structured semantic models for web search using the click-through data. And the background of the web search include the lexical matching search engines which retrieve web documents by matching the terms in the document as like in the search query. But this is suboptimal because it has a language inconsistency between the document and the query. So here we come with the semantic matching, which is used to bridge the gap between the queries and the document. So the problem statement of the web search include the latent semantic models such as latent semantic analysis, which intend to map a query to its relevant documents at the semantic level, where the keyword-based matching often fails. So in the latent semantic models, we address language inconsistency between the web documents and search queries. So in this study, we are going to strive and develop a series of new latent semantic models with a deep structure that project queries and documents into a common low dimensional space so that we can relevant the document given a query which is readily computed and also can be made a little amount of distance between them. So here we propose deep structured semantic models and which are discriminatively trained by maximizing the conditional likelihood so that we can click the document given a query using the click-through data. And here's the previous work and the latest invention. The early approaches include the latent semantic analysis, and there are many extensions which were proposed like PLSA, LDA, and many other. So the recent approaches here are the semantic hashing, go beyond documents which have the click signals. Here's the related work of the web search. We initially used the latent semantic analysis and many extensions as mentioned earlier, and the recent approaches include the semantic hashing, click-through data, and deep autoencoders.
Hello guys, I'm Spandana. Now I'm going to explain about two types of latent semantic model approaches. One is click-through data, another one is deep learning. Click-through data is nothing but consists of list of queries and their click documents. It is exploited for semantic modeling to bridge the language discrepancy between search queries and web documents. Deep learning methods have been successfully applied to various language and information retrieval applications. Deep learning techniques can discover the hidden structure and features at different level of abstraction from training data. Deep models are learned in two stages. First, a stack of generative model is learned to map layer by layer a term vector representation of a document to a low dimensional semantic concept vector. Second, the model parameter are fine-tuned to minimize the cross entropy error between the original term vector of the document and the reconstructed term vector. Latent semantic model and the use of click-through data. The use of latent semantic model for query document matching is a long-standing research topic in the IR community. By using the singular value decomposition of a document term matrix of a document can be mapped to a low-dimensional concept vector. In document search, the relevance between a query and a document represented respectively by term vectors Q and D is assumed to be proportional to their cosine similarity score of the corresponding concept vectors Q bar and D bar according to the projection matrix A. In addition to latent semantic model, the translation modes trained on clicked query document pairs provide an alternative approach to semantic matching. Unlike latent semantic models, the translation-based approach learns translation relationship directly between a term in a document and a term in a query. Deep structure semantic models for web search. DNN for computing semantic features. The typical DNN architecture we have developed for mapping the raw text features in a semantic space. The input to the DNN is a dimensional term vector. The figure shows illustration of the DSSM. It uses a DNN to map high dimensional sparse text features into low dimensional dense features in a semantic space. The first hidden layer with 30K units accomplishes word hash. The word hashed features are then projected through multiple layers of nonlinear projection. The final layer neural activities in this DNN from the feature in the semantic space.
DNN model. It is used for web document ranking to map term vectors to their corresponding semantic concept vectors. to compute the relevance score between a document and a query as constant similarity of their corresponding semantic concept vectors. Word hashing. Word hashing. This method is based on n-gram, and this method is represented using vector of n-grams. One problem of this method is collision. Two different words could have the same letter n-gram vector representation. N-gram word hashing. Below is the implementation of the n-gram and word hashing with fixed linear hashing. Proposed solution DSSM, Deep Structured Semantic Model. DSSM consists of list of queries and clicked documents and with us propose a survivors training method. We calculate the probability based on different vectors. We calculate the likelihood of the clicked document using the training set.
Here's how we have obtained the implementation. We have used the trained dataset and the validation dataset using the click-through data. And also there are three hidden layers based on the fixed projection matrix. They are word hashing layer, hidden layer, and the output layer. And then going on to the evolution datasets, we have used the large-scale retrieval models which are called the evolution datasets. This performance of ranking models is measured using the normalized discount cumulative gain on the scale of 1 to 10. And also our ultimate research goal is to learn the semantic models to give the rich click information. And then here are the results of the web search. The main results of the experiments are summarized in this table, where we have compared our best version of DSSM with three sets of baseline models. And then here we have used the TF-IDF, which is the baseline model, where both documents and queries are represented as the vector terms with term weighting, and also WTM as well as the BLTM PR. Here we have evaluated a series of new latent semantic models, and also we have used the click-through data for optimization, and then we have used the deep learning framework for the successful speech recognition, and then the n-gram based word hashing technique. And here's how we have succeeded to find out the web search using the click-through data and the semantic models. And thank you.